Welcome back to the video lectures of mechanical vibration. In the few video lectures we have seen the free vibrations or the free damped vibrations. In that system we are only considered mass and elasticity of this member. That's we are considering mass and the spring system, we can say that is the vibrating system, or we can say that is the mechanical system. When it comes to when we are adding the external member to that system or within that system, there are going to be when that vibrations are going to be dying out in the motion, in that few cycles of that motion, we can say that there is a vibrating system existed in that mechanical system. So in this video lecture we are dedicating for the free damped vibrations, how it is going to be developing and how it is going to be die out at the few cycles of the motion we are going to be discussing. So here, so that we can say that is the free damped vibrations. So what is the definition of the free damped vibrations? So there we can see the damping is the resistance. So damping is the resistance offered by a medium or a body to the motion of a vibrating system. So here the damping is the resistance. What is the resistance here? As we come across in our life also, the resistance force is going to be developing when a body is moving in the forward direction. There we can see in the different types. In our life also we experience that part. So in that case, that resistance is offered by a medium or another body that to the opposite to the motion of a vibrating system. So here that medium, how the medium is going to be existed here. That medium or the body is going to be existed, that may be the resistance may be applied by a liquid or solid internally or externally. That's we can see here. So that damping, that means this damping is going nothing but a resistance. That resistance force is offered to that motion of the body. Maybe it is going to be a liquid or maybe a solid body. Sometimes we experience when we are moving on the vehicle. So when the speed is going to be increased just 20-30 kilometers, so then what happened? The air resistance is going to be coming to our face. So then we feel that it's trying to stop our motion, right? Because our force is going to be more than the resistance force. That's why we are overcoming and we are going forward in the direction, right? So that's why what we say that the damping may be applied by the liquid or maybe the solid. That's going to be the internal or external forces of that system. So here the same examples we have given our regular life examples here. What is that one? The motion of the car wheels in water. So then the resistance, resisted by the water itself. As we see that when the vehicle is moving in a water, that means the rotating object of the vehicles is the wheels. The wheels are moving in a water or a liquid, then automatically what will happen? It's going to be, that motion is going to be, the liquid is going to be trying to stop it, right? That also we experience when by our itself we are running in the medium of air. So we do have a lot of velocity is available. But when we are moving in the water, but the same velocity we can't maintain, but after few meters distance, we automatically, our energy we are going to be losing heavily. So that we observe here. That means that energy we are going to be dissipating that was absorbed by the water itself. The next over here, so the wheels of the car put to some resistance or the friction because of the road surface while moving on it. This is also we come across the many in engineering mechanics or in automobile engineering. That's we know that when the wheels of the automobile is moving on the horizontal surface on the road, as we know that the friction force is going to be developing between that wheel and the road, then that friction force always opposing the motion of the wheel. So in this way the resistance is going to be developing to that vibrating systems. Then what happened? Because of this resistance, because of this damping or the resistance, the vibrations die out over a few cycles of motion. So this way that's going to be total vibrations are going to be dying out. So in this case we have seen that the damping system. The damping system has the three characteristics. First one is going to be the mass, second one is going to be the stiffness, and third one is going to be the damping. On this basis, we are going to be developing the equation of motion or characteristics equation to study or analyze the damping of the system, right? So here that we are going to be explaining mass, stiffness and damping are the main characteristics of a vibrating system, particularly in the free damped vibrations, right? Out of these three, the first two are the inherent properties of the system. That's already we have discussed in the basic fundamentals of the vibration system. There what happened here, the mass and the stiffness are the mass of the spring of the system, that is we are going to say elastic member are the inherent properties of the system. So then if the value of the damping is small in mechanical systems, it will be having negligible influence on the natural frequency of the system, right? The value of the damping is small in mechanical system. Here, what is the damping here? Already we discussed the damping is nothing but the resistance offered to a motion. That means that is the resistance force is going to be developing within the system. Then it is going to be, the resistance force is very small in mechanical system. Then what happened? That influence of this damping is going to be negligible. On which one? On the natural frequency of the vibrating system. So this way we are going to be seeing. But if the case is that if the damping, the resistance force offered by the system is going to be huge amount, so then what will happen? So that's we are going to be discussing now. We have seen that when the damping is a negligible amount is there within the system, there is no influence on the natural frequency of the system, right? That's maybe is equal to the spring and mass system vibrations only it will going to be taking. But if the damping force is going to be more within that system or due to the external, so then what will happen to that one? Then the vibration system has some energy which is dissipated during the motion. Because this is the damped free vibrations, what will happen here? The vibrating system has some initial amount of energy. At the same time, during the number of cycles in the motion, automatically, so that vibrations are going to be slowly dying out. So then, what will happen here? So at the start of the vibration motion, the amplitude vibrations is maximum, which goes on decreasing and finally is lost completely with the passage of time. So in this case, so this is going to be the vibrations I am going to be taking. So this is going to be your displacement and this is going to be the time. So I have taken this graph. At the initial stage, these vibrations are going to be very maximum and slowly it is going to be decreasing with respect to time or the number of cycles. So this way the energy of that system is going to be losing because of a damping force. So then the rate of decreasing the amplitude depends upon the amount of damping. Here the rate of decreasing the amplitude, that mainly depends on the amount of the damping which offered by that system. So along with that one, when this energy of the system is going to be dying out for the few cycles of the motion, it is going to be more welcome aspect in that mechanical system. So then what are the main advantages? Suppose if you provide this damping system within any vibrating system, so then what will happen? Its main purpose is to control the maximum amplitudes within that system so that we can avoid the meeting the resonance. As we know that the resonance is going to be occurring when the external excitation is going to be meeting with the natural frequency excitations, then the resonance is going to be occurring. The main purpose here is the damping in a mechanical system is just to control the amplitude of vibration so that the failure occurring because of the resonance may be avoided, right? These are the dampers also we have seen mostly in the two-wheelers also. The telescopic shock absorbers are there in front as well as the back. There is a shock absorbers also going to be there, telescopic. So then what will happen when the vehicle is going to be moving in the rough roads, then we can see those going to have the vibrations are going to become. So then what will happen here? So these dampers are going to be absorbing that energy. But when it comes to the four-wheelers or maybe the six-wheelers, buses, trucks, there we are using the leaf springs we are using. Those leaf springs also behave like, because they are going to be absorbing the excessive energy from that system, and then finally at few cycles of time it is going to be make to die out. So this way we can develop the mechanical system by using the dampers.